Question 12a. Use mathematical induction to prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5 for n greater than or equal to 1. The first step is to show the statement is true for some value of n. And in this case, the smallest value of n that we can test is n equals 1. Substituting n equals 1 into the statement, we have 2 to the power of 3 minus 3, and that equals 5, which is divisible by 5. Hence, the statement is true for n equals 1. Next, we assume the statement is true for n equals k. That is, 2 to the power of 3k minus 3 to the power of k equals 5a, where a is an integer. Next, we show the statement is true for n equals k plus 1. So where we have k in the assumption, we're going to replace that with k plus 1. So 2 to the power of 3 outside of k plus 1 minus 3 to the power of k plus 1. Expanding the brackets, that equals 2 to the power of 3k plus 3 minus 3 to the power of k plus 1. And that equals 8 multiplied by 2 to the power of 3k minus 3 multiplied by 3 to the power of k. Now 2 to the power of 3k can be replaced with 5a plus 3k from the assumption, just by rearranging this equation and making 2 to the power of 3k the subject of the formula. Expanding the brackets, that equals 40a plus 8 multiplied by 3 to the power of k minus 3 multiplied by 3 to the power of k. And we have two terms here that are like terms. So combining the like terms, that equals 40a plus 5 multiplied by 3 to the power of k. And factorising 5 out from both terms, that equals 5 outside of 8a plus 3 to the power of k, which is divisible by 5. So therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1.